Hello, in this video we're going to be talking about mutations, so let's not waste any of your time. Let's get right to it.
It's hard to breathe, but that's alright. Hush.
Now when we're thinking about mutations, we want to think back a video or two, DNA repair, the process that the cell goes through to make sure that DNA is read properly. But unfortunately, mistakes can be made, mutations can be made. So what we have is, what we're going to look at is just a series of mutations that can occur. And this is not the entire list. This is a list that we're just going to focus on. But it's the idea of some change has occurred in the nucleotide DNA, or the DNA nucleotides. And if you think about how this can be affected, if you think about the whole process of DNA, and in the replication, and in the transcription, translation that we talked about in mitosis, it's this idea of, if I make a mistake, say I should have a T there, but I have a C instead, that can change the codon, which then changes the amino acid, which then potentially changes the protein. Now, not all mutations are harmful. Matter of fact, most are not, because they happen in such a way to where it doesn't affect the amino acid that's chosen, which makes the protein, especially if it's in that third slot of a codon. But it can also happen, so it can happen that. It can also happen in ways, chemically, radiation, whatever, can alter that stuff as well. Now, if the mutation occurs in a body cell, say one of your skin cells develops a mutation, that isn't going to be passed on to offspring. That's just you going to have to deal with that if it's a negatory situation. But now, if the mutation occurs in the sperm or the egg, then it could be passed on to the offspring. But just a few of the mutations that we're going to take a look at. Deletion, this is a pretty simple one. Due to a breakage, or somehow when they're separated, they don't separate well and it tears off, but you just got a complete removal of one section of DNA. Okay, you've got an inversion. Okay, so it separates somehow and then flips and then is put back in there, or essentially just flips somehow to where now you've got the letter combination. If it was ATA, well, that wasn't a good example. If it was CTA, now it's ATC. So you can get a change again, a change in amino acid that are chosen, and which then ultimately could change the protein. Oh, I see why I was thrown off. I didn't number the first one. That's why I was staring at that. So actually, deletion should have been one, and then inversion, and then duplication. So duplication, just simply as the name says, if you have like an ATC, maybe you duplicate the T and the C, and that's right behind it. So now it goes ATC, TC. So again, that can throw off the codon pairings, and that can again alter the amino acid, which can change the protein. Translocation, okay, it involves two chromosomes, but essentially it's kind of like the crossing over, except without the trade. Translocation is simply one chromosome, parts of the chromosome is broken off, but it's inserted into the new chromosome. It gets into there somehow. That's translocation. A missense mutation, okay, is just a change in a base pair, whether it's a inversion, deletion, duplication, whatever may happen, but something has changed, and then that's going to cause a change in the amino acid strand. Well, that's our video over mutations, and that also is our final video for this video series. So hopefully you enjoyed that and were able to learn a bunch, hopefully, about DNA replication. So we'll see you next time.